So in chemistry, we usually weigh reactants instead of starting with number of moles. We can't count them directly, so we usually weigh them, and that's an indirect way of counting. So let's say we have the reaction combustion of natural gas with oxygen to produce carbon dioxide plus water. So that would be our balanced equation. And say we start with 10 grams of methane and 20 grams of oxygen. How much CO2 is formed? So first we'd have to find if there is a limiting reagent. Now remember, we start with grams. The balanced equation counts number. So we'll have to convert from grams to number. And we count molecules using moles, just like we count eggs by dozens. We count molecules and atoms with moles. So we'll convert from grams to moles so that we can have a number of the amount of methane and oxygen we start with. So let's do that first. We have 10 grams of methane, and we use the molecular weight, adding the weights from the periodic table. So that would give us 1 mole of methane weighs 16 grams. So that gives us 0.63 moles of methane. Now we start with 20 grams of oxygen. So 1 mole of O2 weighs 32 grams from the periodic table. And so this will give us also 0.63 moles of O2. Now we can find the limiting reagent. So we'll just pick one. We'll say 0.63 moles of methane. And we use the stoichiometric coefficients from the balanced equation to convert to moles of oxygen. So 2 moles of O2 per 1 mole of methane from the balanced equation. That will give me 1.3 moles of oxygen needed. But I only have 0.63 moles of oxygen. So oxygen has to be my limiting reagent because I don't have enough to react with all of the methane. Start with my limiting reagent to determine how much product I can form. So I have 0.63 moles of oxygen from the balanced equation. I have 1 mole of carbon dioxide per every 2 moles of oxygen, and that will give me 0.32 moles of carbon dioxide. This is the amount of carbon dioxide that can be formed from those starting weights. Now we can convert moles of carbon dioxide to grams. There are 44 grams per mole of carbon dioxide, giving me 14 1.1 grams of carbon dioxide produced. We have to go from grams to moles because this is what the stoichiometric coefficients in the balanced equation represent, and then we can convert back to grams once we have the total number of moles of product produced.